Hello, welcome back. In this segment, we're going to solve some more problems with arrays. So hopefully, the more code you write, the more comfortable you'll get with manipulating arrays, and we'll just make up some problems that might be useful, demonstrating some useful techniques. Well, suppose that we have an array and we don't know how many elements we need at the beginning of the program, so we just declare some large array and we fill in the data into the array as we acquire it. So we have two things then. The size of the array is how much space was allocated for the array, and the effective size of the array is how much data there is stored in the array at any given time. So if you look at this declaration down at the bottom, we declare an array of doubles called big that has a size of 100 but an effective size of 0 because there's not any data in it yet. What we want to do is to write a function that will add one more value to the array of doubles, ask the user to input the value, and increase the effective size of the array. We're going to return the value that was entered, and we're going to put that value into the array. Write another function that will print out the data currently in the array. That one should be pretty easy, and we're going to demonstrate that those functions are working. So I'll take this spec into the development environment and we'll work on it piece by piece. Okay, so this might be a good time for you to pause and get your development environment caught up with this. I took from the slide the specification. We're going to write a function that will add one more value to an array of doubles. So here's the declaration. We have an array of doubles called big, and there is no data in it yet. We're going to write a function that will ask the user for a value to put into the array, and we will put it at the next location that's unused. So when we start this at the beginning, the effective size of the array is 0. The first data element entered will be put in that location, in the 0th location, and then the effective size of the array will become 1. We're going to pass the effective size of the array by reference because we need the function to actually change this value. So the first time we call it, there's a 0 going into the function, and there will be a 1 coming out of the function using this single parameter. This is also a pass by reference. All arrays are passed by reference. The name of an array is a pointer to the first element in the array. We also see in the spec that we're going to return the value that was entered and put into the array. So the value that the user entered is going to be returned from that, perhaps as a verification that the function operated correctly. So I'm going to change this function call to indicate that it does return something, and it will return the value that was entered. So let's make the prototype for the function getAValue. It will return a double. It will be called getAValue. It will take an array of doubles, and you can use either subscript syntax. Let's use subscript syntax instead of pointer offset syntax. And the effective size is going to be an int pointer. So there's the prototype, and let's copy that and put it down here. This will be the function definition. I'm going to call it a different name inside of the function just to prove that we can, and the int pointer will be called effective size. That also should be called, maybe following our previous convention, p effective size, because it's a pointer to the value that was passed in. So we're going to prompt the user to enter a double, and we're going to scan that double value, so it'll be a %lf. And where do we want it to go? Well, we want it to go into the array called data at location p effective size, and we need an ampersand there. And then we want to increment p effective size, and there's a bug. We talked about this bug in a previous segment. What is the increment operator incrementing in this statement? It would be actually incrementing the address of effective size, which we don't want to do, so we're going to force the dereference operator to happen first, and then we will have the incrementation done on the int value. I'm going to set a breakpoint there, see what typing errors I made in this one. Not too serious an error, but an error anyway. Oh, we said we would return a value, and we did not. So we're going to return the value that was entered, and it is in the array at that location, but we have to subtract 1 from it to make sure that we get the correct value returned. Because we had already incremented the variable p effective size, or what's pointed at by p effective size, then we're going to subtract 1 from it during the access of the data to be returned. Well, let's make sure that this is working. Okay, the compilation worked. Let's run to that breakpoint. So in locals we have an array called big, and it has some junk in it. The effective size of the array is 0, and we're going to step into this function. So output a message to the user, enter a double. Let's enter 1.5, and now we have a variable called data, which is the array, and data sub 0 does have 1.5 in it, and now we want to increment what's pointed at by p effective size. So here's p effective size, it's an address, and we want to increment what it points at. It doesn't look like we did it, but I'm going to take this and put it in a watch window, see if we can figure out what's happening here. So what's pointed at by p effective size did get incremented to 1. Oh yes, I know why, because in the local variables, p effective size, yes, this is correct now. I'm not sure why the debugger wasn't showing a 1 there before, but we did increment what was pointed at by p effective size. So now there is one element in the array, and we want to return what's at this location of the array, which should be at location 0. I'm going to watch that one, and it is location 0. So data sub 0 should have 1.5 in it, and make sure that we actually execute the assignment, and we return the value that was entered. So it's a little bit tricky, and you know that I didn't rehearse this, so I'm allowing you to see the mistakes that people make, even experienced people, and the way that you get the code to work is watch what's happening in the debugger so that you can see the mistakes that you make. It starts to get kind of cryptic when you have all of this. I guess that's kind of goes without saying at this point. Let's go back and visit the spec and see where we left off. So we wrote this function, and we want to write another function that will print out the data currently in the array. Okay, let's write that function now. It doesn't need to return anything. We're going to output the data currently in the array, so we'll pass in the double array, and we need to pass in the effective size. So the question now is, do we need to change the variable effective size in this function? If we need to change it, then we would pass the address of the variable, and if we don't need to change it, we can just pass the variable by value. And I'm claiming that an output function doesn't need to change anything, it's just for displaying. So we're going to make that function with a pass by value on the second parameter. So we're going to pass in a double array of data and the effective size of the array, and this one should be pretty easy for you. A simple for loop. Let's put these each on one line. Okay, let's call that function, pass in the array, which we have called big, and the effective size of the array. And to demonstrate that the function that goes and fetches a value from the user is working, we'll call it 3 times, and then we will output the values in the array. See if I've made any mistakes. Okay, let's run this using the debugger. We'll run to the breakpoint, and I think we've pretty much tested that function, so maybe we'll turn that breakpoint off and just continue, which means run to the next breakpoint. So we're going to enter 3 doubles, 1.5, 2.5, 3.5, and we'll go back to the debugger and see if the effective size of the array is now 3, so that seems to be working. Information is coming back out through this parameter, and now output the array we're going to pass in the 3. Let's step into that function with F11 and see that it is spitting out the values onto the console. And it's not. What did I do wrong? Okay, let's see if the data is in the array. Let's add something to a watch window. Let's say what's in data sub 0, for example. It does have the data in it, so there's something wrong with their output statement. Do you see what it is? I mentioned this problem before. When you use output statements to debug your code, you might make a mistake with the output statement, and that makes finding the problems even more difficult. So let's run this again. I think we fixed it now. We need to indicate to printf that we're going to output double values. And I know some of you are sitting there saying, well, if he makes mistakes, how can I ever do this? And it isn't that you want to write code without making any mistakes. You want to be able to see what the mistakes are and go and correct them, and the amount of time that it takes to do that is the interesting part. So I'm going to step over that function call. That means execute the whole thing, and we'll see that it did output the values in the array. Before we leave this, let me point out that we have pass by value and pass by reference. These are both passed by reference. Arrays are always passed by reference because you pass the pointer to the 0th element. Primitives can be passed by reference or passed by value, and we saw both here. This function did not need to change this variable inside the function, but this function did need to change that variable. So we had to pass this one by reference, but we could pass this one by value. Let's go back to the slides now. I want to introduce the concept of parallel arrays. When you declare an array in C, each of the elements in the array must have the same data type. Sometimes you would want to have different kinds of data stored in an array, and you can't do that. You can instead create something called parallel arrays, where you have multiple arrays of different types of data. So suppose that there are two arrays, one representing the account numbers and the other representing the amount of money due for that account. So account number is an int and the balance due is a double. We can't use a two-dimensional array to store that information, but we can use two parallel arrays. So here's two one-dimensional arrays, one called account and one called balance due. The arrays are related by their index. So that means that this account, 34325, owes $46.89. There is no data in the array specifying that this one is related to this one. It's their position in the array that makes them related. So the parallel arrays. And it can make some interesting exercises. For example, this one. We're going to write a function that takes two arrays. They're parallel arrays. That also implies that they're the same size. So one value can be passed in, which is representing the size of the arrays. And we're going to pass in an amount. We're going to print out the account that owes more than the amount passed in. So what we're doing is we're looking for accounts that owe large amounts of money. So if we call our function count large accounts, and we pass in this array and this array, the size of the arrays, and 40.0, we should see that it would print out account 74942 owes this much money, and account 34325 owes this much money. Those are the two accounts that owe more than 40, which is the value that we passed in here. and we're going to return from this function call. This function will return the number of accounts that have the balance larger than the value that was passed in. Okay, so this is a fun exercise. Let's go and set up the program to solve this. Okay, here we are in the development environment, and I've taken the numbers off the slide. So we've created an integer array here of the account numbers and a double array of the balance due, and these are parallel arrays, meaning that this account corresponds to this amount due. I'm not sure if we mentioned this before. I think so. The only time you can leave these square brackets blank when you're declaring an array is when you have an initializer. So C is smart enough to count all of these and decide that that's how big the array is that you're declaring. Any other time you need to put a number in there when you're declaring an array. Okay, here is a call to the function that we're going to write. It takes two arrays, the size of the array, and some amount where we're going to look for accounts that owe more than this much money. So this is in all caps, the size. It looks like it's a defined constant. So let's do that first. Let's define size to be 6. We have 6 elements in the array. Now let's make the function prototype for that function. It's going to return an int, which is the count of how many large accounts there are, and the first parameter is going to be the integer array of accounts, and you don't have to put the name there in the prototype, but if you do, it makes it a little bit clearer. So I'm going to put them in there this time. Double balance due is also an array, and the size of the array is going to be an integer, and that last one is going to be a double. And what will we call that? We want that to be the threshold if they're owing more than that. Let's put amount owed and a semicolon. So there's the prototype, and I'm going to break that line so that we can see the whole thing at once. And let's take the prototype outside of the main, and we'll define the function here, starting with the prototype. I maybe should also point out that if you put a number here inside of these square brackets, it does nothing. The compiler will allow it, but it doesn't actually achieve anything. When you pass an array to a function, you pass only one number, the address of the 0th element. So putting a number in here doesn't convey any more information, or putting a number in here in the parameter list doesn't convey any information to the function. It's having data around that doesn't do anything is probably worse than not having any at all, because it's confusing. Okay, so we're going to make a loop that will go through the arrays. I use I for the index. It's going to go from 0 to less than size in steps of 1. And what are we looking for in the arrays? We're looking for a balance due that is greater than the amount owed passed in. Well, I'm not liking this variable name, and I'm going to go back and change it. I'm going to call it threshold, because the balance due greater than amount owed doesn't make any sense to me. The balance due is the amount owed. So if when I said it out loud what I was using that parameter for, I used the word threshold, and that was in fact a better name. So if the balance due sub I is greater than the threshold, then what do we want to do? We want to increment a count. So we're counting how many there are, and we're also going to output them onto the screen. So let's do a printf, and we will say account and output the account number, %i, and how much they owe, which is a %lf, and let's use 0.2 lf and put 1 on each line. Okay, so what variables do we want to correspond to those % sequences? We want account sub I and balance due sub I. And then when we're done all that, we will return count large. I won't print out anything. I'll just watch this in the debugger and see if it works. So there's the call to the function. Well, let's compile. Don't be too optimistic. Maybe there's some typing errors or some syntax errors in here. And there are. The build failed. Good. Let's find out what happened. When you have build errors, look for the first error and double-click on it. And it says count large is an undeclared identifier. Okay. So in here we need to have a local variable called count large. I hope you aren't getting confused because I've used local variables by the same name. The variables that are declared in the main are only available in the main, and the variables that are declared in the sub-functions, like count large down here, is only available here. So we're going to return that value, so this function call evaluates to the value that was returned. Let's try again. It's quite possible that I've typed another syntax error. If you are not typing any syntax errors, then something is very strange. Maybe you're going too slow. So let's run to that breakpoint. And in the locals window, here are our parallel arrays, the account numbers and the balance due. I'll just check those and see if they look reasonable. And count large has junk in it, a large negative number. So let's step into our function. I use F11 for that and F10 steps. So balance due sub I, where I is 0, this should be false, and it was. Now we're looking at this one, it's false. We're looking at the third one, it's false. The fourth one should be true, and it is. So we're going in and we're going to add 1 to count large. And we're going to output the account number and the amount due. Let's go out to the account 74942-06845. Okay, that seems to be working. One more should be true. It's this one, and this one should not. That should be the end. There we go. Okay, and count large, the value we're going to return should be 2, and it is. So we'll return to the caller now. And there are the two accounts that owe more than $40. Okay, parallel arrays. We couldn't use a two-dimensional array because we want this row to be integer data type, and we want this row to be double data type, and arrays always have the same data type in all of their elements. Here's the function that takes the two parallel arrays, the size of the array, and the threshold, which we decided is a better variable name, the threshold, which will be the test to decide what is a large account. Okay, let's go back to the slides and look for more specs. Okay, using those same parallel arrays that we had in the previous example, we're being asked now to write a function called getAccountBalance that will take the two parallel arrays, the size of the arrays, and an account number. So we're going to look for the account number, and we're going to return the balance due. So if someone passed in 67567, the function would return 23.50. And if the account number is not found in the array, then we would return -1. -1 indicating to the caller that the account that they're asking for doesn't exist. And another one called getLargestAccount. Take those two arrays, the size, and return to the caller the account number and the balance of the account with the largest amount due. Okay, this one is interesting. I'm going to leave this one as an exercise for you, getAccountBalance, because I don't believe there's anything new in that one from what we had just done. GetLargestAccount has to return two things to the caller: the balance of the largest account and the amount of the largest account. Well, we cannot return two values using a return statement, so we're going to have to use pointers. We'll return those two values to the caller through the parameters. Let's have a look at how getLargestAccount would work. Okay, I brought the spec of this function getLargestAccount over to the development environment, and I'm going to make this a void function because the information will not be returned through the return type, it'll be returned through the parameters. So get largest account, it's going to take the same parameters as the previous one, the two arrays and the size. We'll start with that. And we're going to return to the caller the account number and the balance of the account with the largest amount due. So we're going to need an int pointer type for a pointer to the account number, and a double pointer, which will be a pointer to the largest amount due. Okay, so let's take that prototype and go and implement this function. So we want to find the largest account. So I'll start with a variable called large account, and I'll say that it's 0. And then we will look for the largest one, and we will look for the location of the largest account. So let's make a for loop. I need a variable I for the index. So we're going through every element in the array, and this time we're looking for a balance due that is greater than this temporary variable which stores the largest account. So if we find one, then large account becomes that value, and the location of where we found it becomes I. Now we want to pass back to the caller through the parameters. P_account is going to be the account number, the one at location, where we found the largest location, and P_amount is going to be balance due sub location. Okay, let's have a look at this and see if it makes sense to us now. We're going to loop through the array, and we're going to say if we found a balance due larger than the current large one, then that becomes the current large one, and the location that we're at becomes the location of the largest account. Okay, it's making sense to me. I'm not sure if it's making sense to you or not, but let's call it so that we can step through it in the debugger, and maybe that will help us to understand. So we're going to pass in the two arrays and the size of the array the same as we did the other time. And we need a place to store the account that is the maximum amount due and the amount. So let's say we need an integer that would store the max account and a double that would store the max amount. And we're going to pass the address of max account and the address of max amount. Because we need a pointer here, you might be tempted to declare a pointer and pass that in. But what we're trying to do is we're trying to get this value, this account number, available in the main. If we don't have an integer variable to store it in, then we wouldn't have any way to make it available. So we declare an integer and pass the address of that integer when the function is requiring a pointer. So this pointer is going to point at this variable. I'll set a breakpoint here. I better compile and make sure. I always think that I'm going to type the code without any errors at all. Well, I did that time. Okay, the balance due, which one is the largest? Well, it looks like 0, 1, 2, 3. This is the largest amount. So at location 3, we have 0, 1, 2, 3. 74942 is the account number that we're looking for, and this is the amount that we're looking for. Let's run to that breakpoint, step into the function with F11, and then start walking through it with F10. So we have a large account with 0 in it. So the first one that we find will be larger than 0. And now we're going to say, well, the largest account so far, having looked at the first one, is 19.95, and the location is 0. So far, looking at the first one, we found that the largest account so far is the 0th one, and now we're going to look at position 1, and we found that it's larger. It's 23.5, And if we keep looking, we will find an even larger one. Yes, 68.45. And we're not going to find anything larger than that. Okay, so the purpose of these two statements are to get the values back to the caller through the parameter. Account sublocation has the account number in it 74942, and we want that to go into what's pointed at by p_account. And similarly, the largest amount will get passed back to the caller using the second pointer. Now we're back in the caller. Let's make sure that max account and max amount have the values that we expect. So max account has 74942 and max amount has 68.45. So this seems to be working. I'm not bothering to print things out. I'm leaving all of that up to you as an exercise for the reader. If you're asked to write functions that achieve some goal, you probably should be demonstrating using output statements of what the data is you're working with and what the response of the function is, or the behavior of the function should be printed. Okay, let's go back to the slides. In this next exercise, what we're going to look at is working with arrays of strings. So in the previous segment, we talked about strings in C as a one-dimensional array of characters with a null character at the end. Well, one string is not so interesting. Suppose we had lots of strings. For example, in this declaration at the bottom of this slide, we have a bunch of people's names, and we want those to be stored in string variables. So look at this declaration. We have a car pointer, its data type is names, and it's an array. So you can think of this as an array of car pointers. Each of these has the data type of car pointer. An array of car pointers can be written like this. Remember that the name of an array is a pointer to the first element in that array. So this is only one of the ways that you can declare an array of strings. You could say it's a car pointer pointer. Let's look at a picture of this. Okay, so here's the variable names, and it is an array of how many elements? Well, 1, 2, 3, 4. There are 4 elements in this array, and each element in the array is a string or a car pointer. So here's one string. It's an array of characters with a null terminator. And here's another string, and then I got lazy and stopped drawing the little boxes. But this is, you can think of this as a two-dimensional array, which is in fact what it is. This is location 0, 0. This is location 0, 1, location 0, 2, and so on. Think about what are the data types of each of these things. Names sub-0 sub-0 is this guy right here, and its data type is a car. What is the data type of names sub-0? It's this guy right here, and its data type is a car pointer, or conventionally we would call this a string. And what is the data type of names? It's a pointer to a pointer, or it's a car pointer pointer. This is called double indirection. When you have the address of an address, and I know everybody's rolling their eyes right now, but it's not that hard. An address is just a piece of data, and it's just a number. So it has to be somewhere, and where it is its address. So the address of an address, and we can probably not use 3 of these, although it's quite possible, and there are people who do triple indirection, addresses of addresses of addresses, but pointers to pointers is as far as we're going to proceed. And we can think of this as, you don't have to think of it as double indirection when you have an array of strings. You can think of each of the strings as one thing. So this Bob array of characters, you can think of that as one string. So this two-dimensional array, names, you can think of it as a one-dimensional array of these things. Okay, let's start looking at how we might use this in an application. So we're going to deal a card, and we're leading up to maybe writing a card game. Earlier on, we looked at how to generate a random number, and we're going to use that rand function in this application. And this was how we generated a random number in the range of 1 through 6. You might remember rolling dice a few segments ago. So we're going to deal a card, and we're going to print out the suit of the card. It will be hearts, diamonds, spades, or clubs. And then we're going to print out the face of the card, 2, 3, 4, and so on up until ace as the highest card. So how will we do this dealing of cards? We're going to generate a random number from 0 to 3 and another number from 0 to 12, and we'll use those random numbers to output a card. And the spec then says deal a hand of 5 cards and deal 4 hands of cards, so dealing 20 cards. Okay, well, let's go into the development environment and see if we can write a simple program that will deal a card. Okay, so we're in the development environment, and I copied from the slide the declaration of the arrays suits and faces that we're going to use for dealing a card. So let's start by making a function prototype. I'm going to say it's void deal a card, and to deal a card, what will we need to have? I guess we'll need to have the suits and the faces. To start with, let's make the prototype the array of suits and the array of faces. I'm going to define a couple of constants to be used in here. In caps suits, there are 4 of them, and in caps faces, there are 13 of them. And I finished filling in all of these strings. So let's call our function deal a card and pass in suits and faces. Now let's define the function, and I'm going to take this with me because I already typed it once. And I want to compile from here to see if I've made any mistakes. If there are mistakes, I want to find them before I get too much stuff in here. Okay, nothing so far. So we have a function that doesn't do anything, but it does compile, and it has these 2 parameters, suits and faces. Let's declare 2 int variables, suit index and face index, and we're going to generate those randomly. So suit index is going to be a random number modulus 4. That will generate numbers 0, 1, 2, and 3, which would be useful indices into this 0, 1, 2, and 3. Okay, now let's generate another random number for face index. We'll call the random number generator and ask for a number in the range of 0 to 13. And now let's print out our card that we've generated. We're going to use %s. %s expects a car pointer or a string of %s and a carriage return. So we're going to say faces sub face index and suits sub suit index, and I'm not sure if that's going to work. Let's compile it, see what happens. It feels okay. Okay, I'm going to just bravely run this. I'll put in the system pause, and I'm going to run it without the debugger just to see what happens. So this will have to compile again now that I had forgotten to put the system pause in. So we call the deal a card function 1 time, and we deal the 9 of diamonds. Good. Let's run it again, the 9 of diamonds. And if we run it again, the 9 of diamonds. It doesn't sound like a very fun card game. Do you remember what the problem is? We need to seed the random number generator, and we seed it with the time, the current time, and you have done this once before in an earlier segment, and we have to include time.h. Let's see what that does. So we seem to be getting various cards now, a little bit more random, and there's the 10 of diamonds. Okay, so that was kind of fun. It didn't take very much code to generate two random numbers and use that as indices into this array. Now, it's said in the spec to deal a hand of cards instead of dealing a single card. So I assume a hand of cards is like a poker hand of 5 cards. And what will we need to deal a hand of cards? Well, we need cards, the same as we had before. And let's make that the prototype of the deal a hand function. And a counter. And we're going to call deal a card 5 times. And we'll pass in suits and faces. Will that compile? Okay, well, let's, instead of deal a card, let's call deal a hand, and deal a hand we'll call deal a card 5 times. I should have changed that before I compile it. I was just kind of surprised that it worked. And here are the 5 cards. What did we get? A pair of 2s. Well, okay. A pair of 2s is better than no pair at all. And that time we had a pair of 10s. I was hoping that it would deal 2 cards that are the same, and it would take quite a while to do that, but we have made no effort to prevent the same card being dealt more than once. So presumably we could have dealt 5 ace of hearts here, and then we wouldn't have a very fun poker game. How would we prevent that? So we have just in this 6 or 8 lines of code here enough code to deal a hand of cards, but we're not dealing out of a deck. And it wasn't in the spec that we should have a deck of cards, but I'm going to add it in here just for fun, for purpose of demonstration, and maybe we can make it into an interesting assignment somehow. An assignment left for the reader. Let's make a deck of cards that has 4 rows and 13 columns. So a 2-dimensional array. And let's put false everywhere. So I'm going to have to define false as 0, and no, I'm not going to use false. I'm going to use available. So it's not too complicated. We're going to initialize the entire array to zeros, which in my definition means that they are available. And I'm going to define taken be 1. So as we deal a card, this array of 4 by 13 represents the deck of cards, and all of the cards are available before we start the game. When you deal a card, we're going to have to indicate in this array that's 4 by 13 that that card has been taken. So let's take deal a hand and pass in the deck. It's a 2-dimensional array, and let's also change deal a card and pass in the deck. Okay, so deal a hand calls deal a card, and it has to pass the deck to deal a card. When we deal a card, we're going to indicate that it is taken. So we're going to say deck sub suit index sub face index is taken. So we set that to indicate that that card has been dealt. But what happens if it was already taken? We're just taking the same card again. So we're going to have to check. We're going to say if it's not equal to taken, then we'll mark it as taken. But what if it was taken? We want to generate another one. Okay, I'm going to change the logic here. Stay with me. I'm going to say while the card that we've generated is taken, generate another one. Okay, I'll go over this in a second. So we generate a random card, and then we say if that card has already been dealt, then generate another one. Just keep trying until you find one where this condition is false. So when that condition is false, we will stop dealing cards, and we'll mark the one that we found that wasn't taken. We'll mark it to be taken so that it won't get dealt the next time. See if it compiles. No, it didn't. I've done something wrong. Well, line is that on? Line 10. My double clicking is not working while I'm recording. I find that really annoying. Okay, one error is deal a hand has too few arguments. Okay. Oh, okay, a very important bug. I'm glad that we did this. When you pass a two-dimensional array to a function, you specify the second dimension. Remember, when you pass an array to a function, you're passing only one number. If you pass a two-dimensional array, there is no way for the compiler to know where one row in the array stops and the next row starts. So you must specify how many columns there are in each row. And this is contrary, or it sounds contrary, to what I said to you a few minutes ago. If you put a number inside where you have a single dimensional array, then it's not meaningful. But if you you must put a number in the second dimension of a two-dimensional array. Good, I'm glad I did this, because some of you would get stuck on that for a long time. So let's see if we've got something that will compile now, or if I've made some other mistakes. Okay, well, that seems to be compiling. Deal a hand. Let's deal a hand multiple times. And at the end of each hand, let's put a carriage return. So I said deal 7 hands. 7 5s are 35 cards. And that didn't take too long. Let's see if we have any duplicates. Are you seeing any? I'm not. I think it's correct. How many hands of 5 cards can you deal out of 52 cards? Well, we should be able to deal 10 hands. There's a loop that goes 5 times. Put the declaration of the integers, all the declarations above all of the executable statements. So let's deal 10 hands from the same deck. What we should see is that the dealing of the last few hands gets slower and slower, because it's harder and harder to randomly generate a card that hasn't been picked. Not very much. What happens if we try to deal 11 hands? That shouldn't finish. We should not be able to deal 11 unique hands. That would be 55 cards from a deck of 52. So what we should see this time, even though it slowed down a little bit, it wasn't appreciable. And it is right now, it has dealt 52 cards, and it's sitting there generate a card that has taken. And it won't come to any, so it's going to sit there for a very long time, unless we Control-C out. And exit from the debugger. Well, this was a lot of fun. Dealing cards. Maybe the next thing to do is to make this into a game. But I'm not going to do that. I'll leave that as an exercise for you, and I'll go back to the slides now. Okay, I think that this segment was a lot of fun. I know it's quite long, and I hope that you were typing along with it and watching how I solve problems in code. I don't type from top to bottom, and I certainly don't type code without mistakes in it. So what can we learn from this? Well, work progressively, get small things working, put them together, use the debugger all the time, draw pictures. When you're using arrays and pointers, it's difficult for me to show you the paper that's lying around my computer right now with all of the arrows, making sure that I understand what's in each array and what pointers are pointing to. But you should be drawing those. It really does make things a lot easier for you. Well, I hope you're enjoying this, and I'll see you in the next segment.